Network connections, testing and mapping cable runs. By the time we're done, you will be able to understand the capabilities of cable testing equipment and actively use it to validate cables and map network ports. And if you're scratching your head on what that even means, don't worry, I'm going to explain it in this nugget. We are at the point of patch panels being installed, Keystone Jack being installed, cables being crimped around the office, and now it's time to test them and create a network map that will become the lifeblood of our physical network infrastructure. But I don't want to get too far ahead of myself because we first have to answer the question, does this thing work at all? Think of how far that cable has come. It's fished through the ceiling, it's been pulled out a hole in the wall, and there was a lot of pulling I didn't include in the video previously that I edited out because it got stuck. I patched the cable in at the patch panel and at the Keystone Jack, and in the case of the wireless access point, I crimped an end on the cable. There's a lot that could have gone wrong in any one of those steps. And that's where our network cable testing equipment comes into play. This allows us to validate that the cable itself works well. Now, these cable testers can vary from a few dollars in the case of something like this, up to thousands and thousands of dollars as in the case of something like this. So what's the difference? Well, cable testing equipment, first off, usually supports multiple cable types. RJ11 represents our phone cable for typical analog phones and is fading away quickly. RJ45 is our Ethernet connections. Coax cable is those BNC connectors, the ones you typically see on cable TV that are a circle with that copper core running through it. So if you look at the top of that cable tester, if we were to pull this out of the foam, you would see different ends that you could connect to it. And some of the more expensive ones actually have changeable tips where you can swap out what kind of connector it uses. Now, the core function of just about every cable tester in existence is to find wiring faults. For example, it's hard to see on this, but you can see that there's actually 8 individual LEDs on this box. What you do is you plug one end of the connection, usually this guy, into the side of the patch panel. So there's your patch panel. You'll run a cable from whatever port you want to test to this little remote widget right here. And then you go to the other end of the cable, so that runs through the ceiling, over the hills, and through the country, to an actual wall jack where you've terminated it. You run a cable from that to this end of the connection. Turn it on and it will light up if all of the individual wires are getting a connection. Very basic connectivity test. The problem with these really cheap ones is they only tell you if there's a major issue with the cable. And not to mention, sometimes they'll even give you false positives and false negatives, depending on the quality of the tester. You've probably gotten the feel just from my warnings already about these devices, you don't want to get one of these. They're better than absolutely nothing, but not much further than that. As you get into the more advanced testers, you'll get other features like tone generation. So they'll actually be able to send tone down the line. For instance, I can come to a wall jack and I go, I wonder what patch panel port, so here's my patch panel, what patch panel port does this connect to? So I can send tone down the cable, then come over here to the patch panel and use this little wand to determine which port the tone is coming out. It helps me identify which wall jack maps to which patch panel port in an unmapped network. Some of these can tell you the cable length, so it will actually be able to tell you through the wall, out the cable, how long total is that connection. That's really good to see if somebody's run a cable too far. Some of the really nice ones will give you the fault distance, meaning maybe when you were fishing it through the rafters, you went around a corner and it cut some of the wires in your cable as you wiggled it back and forth against some sharp metal. Some of the testers will be able to say, about 30 feet down the cable, you've got a break in your line. Some of the testers have Ethernet capabilities, and that means they can actually pretend to be a device connected to the network. So it will be able to tell you the speed of the cable. It'll even send some test data down the cable to see if it was received at the other end. It'll be able to tell you what voltage it's receiving via power over Ethernet, because nowadays switches can actually send power so they can power video cameras and phones. And there's different levels of voltage that it can send. Some of the testers will have the ability to link and blink the light. Meaning, in order to tone cable out, you actually have to disconnect it from the switch. That can be disruptive. So rather than doing that, you can have the network tester cause the light or the link on there to go up and down and up and down and up and down. So you can actually look at the switch and see if you see one of the lights on the switch going blink, 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 on, off, and quickly identify where it's plugged into. Some of the cable testers includes mapping remotes, such as this. Each one of these little RJ45 connectors, that's what's on the other end of these in the foam, can be plugged into the wall, and each one has a code, like this is 1, 2, 3, 4. So you can go around an office that you have yet to map, plug them into the wall all over the place, and then go to the patch panel and plug this in to each one of the patch panel ports, and it will tell you what connector is plugged into the other side. That can hugely increase your speed of mapping out a new building. Now, when you start looking for cable testing equipment, you will find all kinds of it available out there and wonder which one is good. In my personal experience, I have found Fluke Networks, Idea, and Klein products to make the best stuff. Now, you'll find out quickly, Fluke Networks is the name in cable testing equipment, and you can pretty much double the price of what you would pay elsewhere to get some of their stuff. I own one piece of Fluke Network equipment, and it's a toner like this that somebody gave me, and I was like, oh, it has the Fluke name on it. It is really good stuff, but really expensive. Idea and Klein products make some really good stuff that isn't quite as expensive as the Fluke equivalent. So before we start using these cable testers to test the cables that we've run, I wanted to give you a little feature preview of each one of these. First off, I have two testers here. My old trustworthy one, very simple, very inexpensive. It's an Ideal VDV Multimedia. I don't even think they make this anymore. Just does basic cable testing and tone generation for RJ45, RJ11, and coax cable. This guy right here I just got, and I'm rather excited about him, does the same thing, basic cable testing for RJ45, coax, and RJ11 cable, but also has the ability to do network mapping with these little remote ID devices. Here's the basics on how they work, and I'll start with my little guy right here. Each one of these testers has a local and a remote probe sensor. If I wanted to test a cable, all I need to do is connect the RJ45 to the local, and then connect this to whatever the remote is. Now keep in mind, this can be running through walls, this could be going through patch panels and all that kind of stuff. I'm just showing you the features right now. I hit the data button on this, and it shows me that this passed. All the wires line up inside, wire 1 to wire 1, wire 2, wire 2, and so on and so forth. I'll move that a little closer to the camera just so you're able to get a good look at it. Same thing with this guy over here. Remote sensor, I'll connect the RJ45 cable to this end and to the local sensor itself, hit the network button, and sure enough, I see it passes 1, 2, 3, etc. all the way across. If the cable is disconnected or something is wrong, we'll actually come up and say fail, open. You can see all the numbers across the top, and it's blinking because there's nothing on the other end. If one individual wire didn't connect, you would get the same result, and it would identify which wire has the problem. If I wanted to send tone down the cable so it can be identified, and I'll show you how this is used in a little bit, I can connect the cable and hit tone. It actually is sending tone. This is my Fluke Networks probe, most expensive probe out there. I take this and I run it to the other end of the cable, and I can see that this is generating the tone. If I didn't have that cable nearby, I'd just do a quiet hiss. And it's still, even from this distance, it's picking up the tone that this guy is generating. So I don't have to be right on the tip. I could be on the outside of the cable, and it would be able to tell that tone is being generated down that line. If I wanted to identify wall jacks, I could use these little remote IDs, plug it into the wall jack, which I'll emulate just by connecting directly right here, hit the OID on this, and it says, oh, I've identified number 6. So again, this little widget right here could be far, far away through walls, and it would be able to identify that that widget is plugged in. If I wanted to test the length of the cable, I would just connect the cable or plug it into the wall and use this button, which also generates tone and tells cable length. So I'll hit this button, and it comes up and said the length of that cable right there is 3 feet. I'll grab a little longer cable and plug it in. I don't know how long it is in that spool. And notice there's nothing plugged into the other side. I'll hit the length button, and it says this one is 14 feet. Isn't that amazing? All right, that should be enough of an overview to get us started. So what I've got now is I've moved this desk back. This is the wall jack that we installed, but I don't remember which patch panel port it actually lines up to. So I'm going to take my cable tester. I'm going to hit it on tone, so it's generating tone. Can verify that tone is coming out of there, and I'll plug it right into that wall jack. Now I'm back at the patch panel, and what I can do is I can take my probe and put it in each one of these. I'm listening, I hear static, static, static. Now, sometimes you're in a network room that is just a mess, and then sometimes it just benefits you to stick this thing into the blob of cables and see if you can hear tone coming from one of the cables, because it does pass through this shielding. Now, keep in mind, you will not hear tone if that cable is plugged into something, meaning if it's patched into the switch or something like that, the tone will be disrupted. But in this case, I remember it was somewhere around 35, 36, 37, 38. Whoa, hear that? Right there, port 39. So I know that port 39 is actually running to that wall jack behind that desk. Now that I know where it's going, I'm going to plug in a cable to port 39 and attach my remote probe. Now back over here, I'm going to disconnect my little Ideal tester. I used him just because he was a little lonely and wanted to generate some tone. I'm going to connect my new Klein Tools tester, hit the continuity button, meaning test the cable, and sure enough, we've got a pass. And that makes me feel awesome about that cable run we did to this wall jack. I'm going to shoot down here to the cable length, and it shows that this guy's about 84 feet in length. Now I want to find out where these cables terminate on the patch panel that are going to be used for the wireless access points. To do that, I'm going to use these remote probe IDs with that Klein cable tester. But since this is a male end, and obviously I've already crimped a cable onto this end, I'm going to use an RJ45 coupler. So I'll take that remote probe ID on one side and plug in the cable to another side. So this guy will be number 7. And now we'll use remote probe ID 8 to identify the cable installed right above the shirt company. Good. Now that we have the remote probes connected, I can come in here and plug into port 38. Nope, open port 40. Oh, right there, ID number 7. That was the front wireless access point cable. And that must mean that port 41 is, sure enough, 8. Now what I was showing you was how to use cable testing tools. However, I had an ulterior motive in everything I was explaining, and that is to give you the skills needed to create a network cabling map. Now, what I'm about to show you on this slide, what did I say there? What I'm about to show you on this slide is probably missing or outdated from 90% of the normal networks out there. That's just Jeremy's guesstimate. IT administrators would love to have something like this. They probably would even pay somebody to create something like this. However, they usually chalk it up to the dreams that will never be achieved. The benefit of creating a good network cabling map cannot be overstated. At a minimum, this map will show the patch panel to port mapping, meaning you have the patch panel in the network rack, has a port, it has a label on there, let's just say 10, and that port goes through the ceiling and the plenum space, through the walls, etc., and lands at wall jack B9. At a minimum, having a document that shows this will help you out in a huge way and probably save you a lot of travel time if you're ever troubleshooting a network environment. Ideally, if you're creating the map, you would do something like this. This is a spreadsheet that shows the patch panel name, and you would need to label the patch panel. In this case, I said S113 representing Suite 113, PP01, that's patch panel 01. So I should have a label printed or engraved on the patch panel, an asset tag of some sort that has that name. Then I've got the port number 1, and I have that all the way down. You can see it's cut off here, representing each one of the ports of the patch panel. Then I have this switch name. Notice all of this is under the source information, meaning this is the stuff that is sitting in the MDF. This patch panel port plugs into port number 1 of US 3001-SW01. Now what is that? That's the name of the switch in the rack. In my organization, we created a code that we call US 3001, United States, site number 3001, and this is switch number 1 at that site. You can create whatever naming convention you want to. I've seen people come up with Matrix characters, Neo, Trinity, as their switch names. As long as it's documented well, it doesn't really matter. However, the benefits of coming up with a naming convention that doesn't use animated or heroic characters is just by hearing the name, it means something. I then move over to the destination information. The wall jack or the port number is next. Now, you can see I just put an example here of this one happens to go to the ceiling. And then I have a location description / destination device. And I can see this one says East Lobby US 3001 WP01, which represents the first wireless access point, that's WP, at that location. Next one over, I have cable type, RJ45 copper, but other things could be in there like coax, BNC connectors, could be fiber optic cable, multi-mode fiber, single mode fiber. There's all kinds of different fiber standards. We'll talk about those later. And then I move into more of the general information. What is the distance from the wall to patch? You figure if you've got the cable tester out there and you're mapping the network, you might as well catch what is the distance and ensure all of those fall within that 100 meter maximum that Ethernet cabling should be running. Maybe as you're mapping the network, you suddenly find one that's 200 meters long. I can't tell you the immense amount of troubleshooting you've just saved when somebody plugs into that port down the road and just gets this strange, intermittent, slow, problematic connectivity. Right next to that, I put the last date tested. These will likely all be the same if you're mapping the network all at once. And then any notes or unique attributes for any one of those ports. That's primarily a free-form field that you can use to put in anything that doesn't quite fit the other fields. Now you also notice the shading that I have in here. It's not just to make it look pretty, it's very intentional. This is meant to be a living document. It's created one time when you map the network, but then every update that you do, such as connecting a new port, running a new cable, moving devices around, you come in here and update this document. That's your only hope of keeping it updated. Otherwise, it becomes an obsolete sheet stored in a folder on your laptop. The blue shading represents devices that are connected. Now, obviously, this is a sample, but this would represent that ports 1 through 8 are actually connected ports. The red ones are ports that are yet to be connected. Maybe ports 9 through 12 of the patch panel are plugged into the switch, but they don't actually connect to any devices as of yet. Those are open ports waiting to be patched in. That makes it so much easier when I'm going to run a new cable instead of what I did in some of the earlier videos of just turning the patch panel around and going, well, looks like we left off right there. That's where our next cable will go. So I'm bringing it back to our objective. I said you would be able to understand the capabilities of cable testing equipment and actively use it to validate cables and map network ports. Now it's time to prove it. Just so you know, I've been working very hard to try and make the theoretical lead into the practical. So you can actually walk through these steps and it prepares you to do the practical steps. On the theoretical side, research the network testing equipment that you would use to do essentially everything that I did in this video and create a template spreadsheet for mapping the building, determining the format and the fields that you would collect along the way, coming up with a standard port naming convention for your network. Do you want to name your switches Morpheus, or do you want to name them SW01, IDF5, etc., etc.? Then for the practical, purchase that network testing equipment that has the ability to test cable and map network ports, whether you're using the tone method or the remote ID sensors. Just to give you a ballpark of what that equipment will cost, the ultra cheap testing equipment is usually $10 to $20. The ideal one that I used to generate the tone, that gray little handheld beauty, that one was $80. The Klein Tools one with the remote ID probes and length capabilities and so on ran about $150. That should give you a range of about what those tools will cost. Then create a spreadsheet for your location, whether it be your house or your office, and validate every port, completing that spreadsheet so you have a cable map, implementing that naming convention that you developed. And now it's your turn to jump in. I hope this has been informative for you, and I'd like to thank you for viewing.